Okay, so based on all the emails I'm getting from you guys, it's clear you guys just are not getting this. So, making my final video and then I just give up. So, I think the biggest problem you guys are having is you're trying to find shortcuts for doing this, and there are no shortcuts. So, I created my own little problem here, and you can see the graph, and I'm declaring that g of x is this other function. This graph is the picture of f. So, if, for example, I ask for g of 0, then I'm not interested in the picture of f. I'm interested in g. So all that means is wherever you see an x, you're going to replace it with a 0. So you don't have to even think about this, because we've said before, if the lower limit is the same as the upper limit, that entire area is 0. So let's try something a little more difficult. What if I said that I want g of 1? Okay, you can't just look at the graph and say, oh, when x is 1, y is 2, because that's the graph of f and you want g. So wherever you see an x, you're going to put a 1. Okay, this notation right here means to find the area under the curve from 0 to 1. So the area under the curve from 0 to 1, whoops, sorry, things went crazy there, is a triangle located right here. So you just need to know that the formula is 1/2 base times height. So the base is 1 and the height is 2, and so the whole thing is equal to 1. If that triangle was located below the x-axis, then you would give it a -1. Always keep in mind that the smaller number has to be on the bottom, the bigger number has to be on the top. If it's not, you're going to switch it and you're going to add a negative sign. Okay, so let's make this a little more difficult. I'm going to erase all this. Okay, so let's say that I'm asking for g prime of 2. Okay, you can't find g prime of 2 until you find g prime of x first. So you already have g of x, you need g prime of x. So I could just add a prime onto the left side, but if I add a derivative on the left side, I have to add a derivative to the right side. Okay, now this is the second fundamental theorem of calculus. So that means that you just take this upper limit and you put it in wherever you see a t. So therefore, g prime of x is equal to just f of x. Okay, the question asked you to find, whoops, g prime of 2. Okay, so just put 2 in now. And so when you replace x with 2, you get f of 2. Okay, this is the graph of f. So when x is 2, here's 2 right here, what is the y value? It's 2. Okay, so that completes that type of problem. Let's try a different kind. Okay, let's say that the question is, when is g of x increasing? Okay, so what you need to recognize is that g of x is increasing when, g of x is increasing when g prime of x is greater than 0. Okay, so the question really is when is g prime greater than 0? Okay, we found before that g prime is equal to f of x. So if I'm interested when g prime is greater than 0, but g prime is equal to f of x, the question is really, when is f of x greater than 0? So you look at the picture, and you're looking at that purple line. And the purple line is greater than 0 throughout this entire piece. So that means that it's greater than 0 in the interval from 0 to 3. So that means that g is increasing from 0 to 3. You're not interested in f. The real question was, when was g increasing? And it's from 0 to 3. Okay, let's try another question. Okay, how about, when does G have a critical point? Okay, so when does G have a critical point? Okay, so what you have to recognize is that G has a critical point when G prime of x is equal to 0 and there's a sign change. But we know that G prime is equal to f of x from what we did before. So the question is really, when is f of x equal to 0? So you look at your picture of f and you can see that it's equal to 0 here and here. But there's no sign change. It was always positive. So therefore there are no critical points. If it went through the axes, then you would say that that's a critical point. Okay, let's try one more time. Okay, how about when is g of x concave down? Okay, so g of x is concave down when g double prime of x is less than 0. Okay, I know that g prime of x equals f of x because we already did that. So g double prime of x equals f prime of x. So if I want to know when g double prime is less than 0, that's the same thing as asking when is f prime of x less than 0. Okay, so there's two ways you can think about it. So one way, and I told Michelle Sherman that I thought she would confuse people, but actually most of you understood it better this way. So f prime means the slope. So when is the slope less than 0? Meaning when is there a negative slope? So if you look at the picture, the slope is actually never negative, because here it's positive. Let me get a different color. Okay, here it's positive, here the slope is 0, and actually here the slope is undefined because it's a vertical line. So when is f prime of x less than 0? Never. So that means it's never concave down. However, if the question asked when is it concave up, then you're looking for when is the slope greater than 0 or when is it positive. And that would happen here. That's when the slope is positive. So you would say in the interval from 0 to 1. Okay, I think that covers everything. Concavity, increasing, decreasing. Oh, okay, I just want to add one other thing. If you want to know when f prime of x is less than 0, another way you could also think of it, this is what I talked about in class today, that f prime of x is less than 0 when f, whoa, things went crazy, when f is decreasing, f prime is less than 0. Okay, so you can look at a picture of f and say, when is it decreasing? The answer is never, but that's another way that you could think of it, because from here to here it's increasing, here it's staying the same, and here there's actually no slope at all, but there's no way that it's decreasing. So you can, when you're thinking of it, the slope decreasing, it also means that, it looks like this. It's a negative slope facing that direction. Okay, I hope this was somewhat helpful.